Why are rational arguments so persuasive? In this video, I'm going to unpick that persuasive power and show you why it's partly justified. But I'll also show you how there's an element of illusion to it too. In a previous video, I explained the definitions of rational and reason that I like to work with. I see reason as our ability to organize and explain our thinking, and I see rationality as our ability to support our thinking with calculations. But how do calculations support an argument? And why is it that calculations can be so persuasive? To explore this, we're going to look at the rise of rationality, the rise of our ability to perform calculations. This is an episode of Go Meta, where I explore ideas in a way that I hope contributes to a culture of healthy public discussion. Anatomically modern humans have been around for well over 100,000 years. And as far as we know, for all of that time, we've been discussing things with each other. We've been using language to organize and explain our thinking to each other. We've been reasoning. And this reasoning would have included the use of our basic ability to categorize and count the world around us. For example, asking, was it deer or bison that you saw? And how many bison did you see? But it is only in the last 10,000 years or so that humans started writing things down in a way that could support calculations. So I'm not here talking about the earliest mark making, where people recorded tallies of things. That is not yet calculation, but merely recording what has been counted. Proper calculation begins when humans started writing things down in a way that could support mathematics with large numbers. While many of us can perform simple sums in our head, it is the tool of writing that is a crucial aid for performing anything but the simplest of calculations. And with that tool, it opened up the possibility of a new kind of argument, a rational argument. For example, imagine you were an ancient trader, and at the start of the day, you knew that you had 3,285 copper coins. And that day, you sell some goods for 37 copper coins. And at the end of the day, your accountant says to you that you now have 3,312 copper coins. But you might have noticed or suspected that there's something wrong with this answer. Without the tools of calculation, this number would be hard to question without recounting all of your copper coins. But we can use column addition to systematically work out what the correct answer to this sum should be. The number given to us by the accountant was clearly wrong. And then, with column subtraction, we can work out that 10 copper coins appear to be missing. It doesn't matter how large these numbers get. By writing the numbers down, we can use the same symbolic technique to accurately work out sums that we couldn't do in our heads. So these calculations using written symbols support the persuasive rational argument that 10 copper coins are missing from the number the accountant gave. Of course, there's lots of debate about the exact dates of the various stages of human development, but I've mentioned some approximate dates here just to highlight the gap between when it was that we started to reason and when it was that we started to use rationality. We have probably been using our capacity for reason for at least 100,000 years since we evolved the capacity for language. Yet it is only in the last 10,000 years or so, since we developed the ability to write things down, that we've been making rational arguments supported by calculations. The rise in our use of rational arguments is an important contributing factor for why the last 10,000 years or so have been so spectacularly successful for humans. But why do calculations help make convincing arguments? Well, we can see column addition as one member of a family of arithmetic calculations, such as column subtraction and column multiplication, that all take advantage of the idea of writing down numbers using columns. This collection of calculations and techniques can be thought of as a rational tool that can be used to support particular kinds of rational arguments, such as the one we saw earlier about the missing copper coins. Once you've learned how to use the tool, you simply put in the inputs, crank the handle, and get out the answer. If you change the inputs, the outputs will change accordingly. But every time you put the same inputs into the tool, you get exactly the same answer out. Rational tools provide repeatable and reliable ways to work out certain kinds of answers. And the answers that they give are not dependent on the mood or personal biases of the person cranking the handle. They only depend on the input values and the algorithm, the steps used for the given calculations. This gives rational tools a certain sense of independence from human interference, a sense of objectivity. And if two people don't trust each other's answers, they can each do the calculations themselves, and they can do it in front of each other, and they can do it transparently, writing down and checking each other's work on every step of the algorithm. The calculations will give the same result with no fear or favour. This sense of objectivity makes rational arguments very persuasive. To be clear, I'm not suggesting that for an argument to be rational, you must do the calculations there and then. No. The idea is that if you claim that your argument is a rational argument, you are effectively making the promise that if needed, you or anyone else could go back and perform and write down all of the steps of the calculations that support your argument. In another video, I will look at the way that logic fits into this picture. But here, our focus has been on the rise of mathematical calculations. The rise of maths helped us build and organize larger cities and civilizations. Continuing this simple historical sketch, we can then see science and engineering as disciplines that build upon these persuasive features of rational tools by adding standard ways for taking measurements and observations of the world around us. This brings a similar sense of objectivity to the input values being used in the rational tools. Scientists and engineers have then gone on to put together a wide range of rational tools that can be used in all sorts of different situations. For example, there's a collection of calculations called Newton's laws of motion that can be used to understand most moving objects. And similarly, there's the laws of thermodynamics that helped understand steam power, and the laws governing electromagnetism, to mention but a few. And we can now use computers to crank the handle of these rational tools. This can give an even greater sense of neutral objectivity, as it then seems like there is no risk of human bias or error in the processing of the calculations. So today, if you want to know when is the best time to launch a spacecraft to Mars, we can answer that question accurately and with confidence. By taking the appropriate observations of the world and then using the right rational tool, we can put together a detailed rational argument for why you should launch your spacecraft in a very particular time window. And we have no other plausible way of answering that question. Scientific observations and rational tools have given our societies amazing capabilities, including the ability to occasionally land space probes on distant planets. But the use of rational tools is not always so straightforward. For example, if you wanted to investigate issues around poverty, should you be using a calculation of absolute poverty or of relative poverty? The answers of your investigation might partly depend on which choice you make. So even though the calculations themselves proceed from inputs to outputs in a neutral way as you crank the handle, it would be wrong to suggest that the answers of your investigation are neutral,
just because you've used a rational tool.
Some hope that one day we will be able to solve this problem by developing a rational tool that will calculate in a neutral way which rational tool we should be using to answer a given question. Indeed, some think that an artificial intelligence will one day be capable of doing this calculation for us. This kind of strong confidence in rationality can be understood as a contemporary version of modernism, a sort of neo-modernism. But there are known limits to what formal systems are capable of calculating, known limits of rationality, and I'll explore some of these in another video. And postmodernists think there will always be elements of political and cultural biases that enter into our choices of which rational tool to use and which measurements to make. Given that people in positions of power are more likely to be able to influence these choices, some think this makes the answers given by these tools an instrument of the powerful, who use the persuasive veneer of neutrality and objectivity to push what is actually a political agenda.
In other videos, I will explore these issues further. But I hope here I've given you a sense of why rational arguments supported by calculations, can be so persuasive and can answer questions that we would not be able to answer any other way. They are extremely useful. But we have to be nuanced in our attitude towards the answers we get from rational tools. While the calculations may proceed in a neutral way, the choice of which measurements to make and which rational tool to use is our choice. I hope you've enjoyed this video, and if you did, please do click on the like button below or subscribe to my channel, as that will encourage YouTube to share this video with more people. Thank you for watching.
And in the description below, you'll find links to more videos and blog posts about the ideas discussed in this video.